Let's take a look at type 3 binary compounds. These compounds are recognizable because they involve nonmetals bonded with nonmetals. Okay. There are no ions here, no cations and anions coming together. We have nonmetals and nonmetals coming together. Okay. So again, binary, two types of elements, two elements. So let's try one. We'll try a very common compound that most are familiar with, CO2. Okay. Why do we name it carbon dioxide? How does that come about? When you have binary compounds that are of the type 3 form, where nonmetals and nonmetals are coming together, how we represent that is using the numerical prefixes, okay, such as di meaning 2, mono 1, tri 3, tetra 4, those various numerical prefixes. Okay. So what we do is we take our formula, the first element, we name it as it is, carbon. We do not typically say monocarbon. If the first element, if there's only one of them present, so just one carbon, we don't say monocarbon, we just represent it as carbon. Okay. It's inferred that there's one carbon. Then the second element is oxygen. So we have oxygen. We change the ending, as we did on type 1 and type 2 binary compounds, from oxygen to oxide. Okay. We gave it the IDE ending. Now, to represent that there are two of the oxygen present in this compound, we use the numerical prefix di, meaning 2. So when we take this name apart, we are saying carbon, one carbon, with two oxygen, two oxide. So carbon dioxide. Another example, let's say we had N2O. Okay, N2O. We take the first element, nitrogen, write its name. Now, we need to represent that there are two nitrogens present, so we use the numerical prefix di. So dinitrogen, meaning two nitrogens, so we have that taken care of. Then we come across and we use oxygen is present, but we're going to change it to oxide. Okay. Now, the second element, if the second nonmetal is a mono, is 1, we do need to represent that. We didn't do that up here. If the first element is a single atom, just one carbon, we don't say monocarbon. Okay, for the first element, we use mono in the second element. Okay, so we have dinitrogen, meaning that tells us two nitrogens with one oxide or one oxygen. So it lets us see the formula as N2O. Dinitrogen monoxide. Now, let's try some the other way. Let's have the name and create the formula. Let's try diphosphorus pentoxide. Diphosphorus pentoxide. So let's take it apart. Phosphorus, there's its symbol. Di is the numerical prefix for 2. So we have 2 phosphorus, diphosphorus. Pent is representative of 5, much like the Pentagon building, 5-sided. So pent is 5, 5 oxide, oxygen. Diphosphorus pentoxide. Alright, let's try another one. Let's say this time we had tetraphosphorus decoxide. Let's take it apart again. Tetra is the numerical prefix for the number 4. So we have phosphorus 4, P4, deca, much like a decade, 10 years, deca, 10, dec. So oxide, oxygen, P4O10, tetraphosphorus decoxide, diphosphorus pentoxide. Okay. Here we have nonmetals with nonmetals. There are no cations and anions involved in these compounds. No plus and minus charges. These are nonmetals that are bonded together forming compounds.